Welcome back. Now I'm going to talk about some very basic concept in spherical trigonometry. Consider that any sphere can be created by rotating a circle around one of its diameters. Now consider this vertical line as the diameter. And if I rotate this circle around this diameter, I create a sphere. Now consider normal to the sphere, and we know that all normals to the surface of a sphere go through the center of the sphere. And now a tangent plane to this normal. What's the sphere in a circle? In other words, the intersection of the vertical plane and the surface of the sphere is a circle, which is called a great circle. Why is it a great circle? It's a great circle because it goes through the center of the sphere. And in this case, this intersection or this circle is larger to any other intersection that we can make at the surface of the sphere. So, intersection of any plane going through the center of a sphere is a circle, which is named a great circle. Now consider 3 points at the surface of a sphere, and we know that a great circle can go through each two of them. For example, we have one here, and I can have another one here, and we can have another one here. This part of the surface of a sphere, which is limited amongst these 3 great circles, is called a spherical triangle. Spherical triangle is a part of a sphere surface, limited among 3 great circles. Let us now focus on this spherical triangle. I name the corners of this triangle A, B, and C, and the angles are named based on the name of the corners. The arc in front of the angle A is named A, or the arc A, and shown by a small letter. Small letter means arc. So the arc in front of the angle B is called the arc B, and the arc in front of the angle C is called C, or the arc C. Now, by naming these arcs and naming these angles, we can define the sine rule. The sine rule says that the sine of an arc over the sine of the angle in front of that arc is constant. In other words, we can write this formula for the relation between the arcs and the angles. Sine of the arc A over the sine of the angle A is equal to the sine of the arc B over the sine of the angle B is equal to the sine of the arc C over the sine of the angle C. So this is the sine rule. Cosine can be defined like that. I explain the first one based on the arc A, and you will learn how to write this identity yourself. So cosine of the arc A is equal to cosine of the arc B, cosine of the arc C, plus sine of the arc B, sine of the arc C, and cosine of the angle in front of the arc A. So look at the formula now. The arc A is here on the left side, and the last part of the formula is the angle A. This angle is in front of this arc, and the rest, this arc, which are not this arc A. So let us write another cosine for the arc B. Cosine of the arc B is equal to cosine of the arc A, cosine of the arc C, plus sine of the arc A, sine of the arc C, and cosine of the angle in front of the arc B, which is the angle B, as you see here. And the cosine rule for the arc C. Cosine of the arc C is equal to cosine of the arc A, cosine of the arc B, plus sine of the arc A, sine of the arc B, multiplied by the cosine of the angle in front of the arc B, which is the angle C. And you see here. So this angle C is in front of the arc C, and A and B are the other arcs or the other sides of this spherical triangle.